Welcome to Ask and Learn.
All right, guys, we're doing problem 34 of chapter 18 in Chemistry Essential Science. So, an important reaction, photochemical smog, is the photodissociation of NO2. NO2 plus H mu, which is the sign for light, yields NO gas plus oxygen gas. So, the maximum wavelength of light that caused this reaction is 420 nanometers. What part of the electromagnetic spectrum is light with this wavelength found? So it's found in the visible spectrum, because the visible spectrum is approximately from 400 nanometers to 700 nanometers. Right, so that's approximately where the visible spectrum is. Now, what is the maximum strength of bond in kilojoules per mole that can be broken by the absorption of a photon of 420 nanometer light? Yes. So we're going to just us. So we're just going to use the formula. E is equal to HC over lambda. Like, that's generic formula, but we're also but we want it in kilojoules per mole, not just joules. So we're going to put an N here, where N is going to be Avogadro's number. So E is equal to 6.63 times 10 to the negative 34 times 3 times 10 to the 8 meters per second over 420 times 10 to the negative 9 meters. Multiply that by Avogadro's number, 6.02 times 10 to the 23rd inverse moles. Also multiply that by 1 kilojoule per 1,000 joules. So this is going to be equal to 285.09 kilojoules per mole. And that's the maximum amount of energy, the maximum strength of bond in kilojoules per mole that can be broken by this absorption of the photon. And now, see, we're at the photodissociation reaction showing the Lewis dot structure. So I'm going to just erase this. So we have NO2 plus we have nitrogen dioxide. Right, so nitrogen dioxide is a bit of an interesting molecule. It has one unpaired electron, which is one of the reasons nitrogen dioxide is a bit unstable. Now, we're going to add light. Plus H mu. So that's going to produce nitric oxide and oxygen. And nitric oxide has this partial double bond. And then we're going to have oxygen. And remember, oxygen has 6 electrons surrounding it. So 1, 2, 3. 1, 2, 3, 4, 5, 6. And that's going to be the Lewis structure for this photodissociation reaction.